Welcome back to ECE 320A. We're in the two-port unit, Unit 12, and in this video what I want to look at is really just sort of outline the steps that you can use. Now that you have these tools, these two-port design tools that allow us to take measured data, that allow us to identify different sets of parameters, and dealing with terminated two ports, can we now use those in a more intuitive or a more understandable way to perform analysis and design? And again, I just want to illustrate that. I'm not going to go through the detailed steps. But let's now look at this from the following example. I'm giving you a particular example just so that you can try to understand what you might have to play with or utilize in attacking some of these two-port design problems or two-port analysis problems. Let's assume that we now have this interconnected circuit, and if you were simply analyzing this, you could simply do a mesh here, a mesh here, and a mesh here, and so you have now three mesh equations, but they're kind of coupled and interconnected. And when you finally find what this current is over here in this lower right hand side, it may be not that intuitive how to select R sub 2 or R sub 1 in order to make that current or the power at the load what you want it to be. Or you could maybe perform some nodal analysis. You have three nodes, but again, you have this coupling that is present, and is there a way to look at this from a higher altitude, do more of a top-down design, break it up into more understandable pieces that you could then select those pieces and manipulate those pieces in a more clear analysis or design scenario? So to start with, instead of thinking about, oh, well, this looks like a two-port, terminated two-port, let's just find the two-port here. Well, again, that involves a fair amount of interconnectedness or coupling to find the four Z parameters, let's say, in that circuit. We have this top piece that's sort of another loop that might make that a little bit more involved. So let's see if we can now try to identify or extract two different two ports, and in particular, what I want to do is see if I can identify two ports that are connected in a series interconnected way. So let's now start to be creative and become a little bit more imaginative as we try to, and really all I'm going to do in these next few steps is start bending and contorting these wires or these nodes that interconnect this, because the wires are ideal. I can move and manipulate those however I need in order to maintain or preserve these four terminals or these two different ports on port 1 side, the left side, or the port 2 side. And I want to now see, can I actually extract or identify two different two ports from this one port, because it might help me do the analysis in a cleaner or a more step-by-step or a more understandable way. First, let me just look and see. I have this top resistor, R1, R2, R3, and R4, and I really haven't changed the configuration at all. I've simply moved these nodes around or bent that wire up to where now it looks a little bit different, and maybe this is starting to seem a little cleaner, but I just need to really preserve this connection and this lead on the left and the right. So now let me actually sort of shrink those down a little bit so that now I have, and let me widen that connection or expand on that particular node. So here I'm going to preserve R sub 1, but now let me go ahead and just slide this point all the way up there and this point all the way up there. And I'm going to extract or bend this wire, lengthen it, so that now I have R sub 2 and R sub 3 right there, and I haven't changed anything relative to the interconnection of these four parameters. And maybe now you can start to see what I'm wanting to do. And now what I want to do is really just build this piece a little bigger. So now I'm really going to just sort of make this node. I haven't really changed anything with what I had before. I still have this node. This is still one node. I've just expanded it or drawn it as an ideal set of interconnected wires, but it's still the same point in terms of voltage or potential. So now I have what I need, because if I look at that in this form, I hope you can start to see that if I started to slice this right here, and I sliced this bottom piece here, I now have a yellow 2-port and a blue highlighted 2-port, and they are in fact connected in series. We now have a series connection, and I can identify the port 1 up above. If I called this Z sub A and this Z sub B, I now have port 1 and port 2 in the top 2-port, and I have port 1 and port 2 on the bottom 2-port. And in fact, these are connected in series by the green highlight, and that allows me now to simply find, and it might be easier now to find the 2-port parameters for Z sub A for the yellow highlighted 2-port, and it may be almost a trivial process to find the 2-port parameters for Z sub B in the blue highlight. And now I can rewrite or re-express or rethink what this looks like in terms of two different 2-ports connected in series. And I can simply combine those 4 different Z parameters in Z sub A with their corresponding 4 Z parameters in Z sub B. And in fact, Z sub A will be this pi network, and I think you can see the pi shape here in that circuit, and so you might hear this referred to as a pi network, but you could then find those Z parameters. You could find the Z parameters for this 2-port network, and we could call those Z sub B. And once we've done that, now we can perform our analysis on that series combination. And it's a terminated network. But Z sub S now, probably we can have a little bit better intuitive feel into how to manipulate those parameters, because now we can look at manipulating R sub 4 or the Z sub B parameters, or we can manipulate these 3 resistors or impedances. We could embellish this as much as we want. We could manipulate the Z sub A parameters because we now have them cleanly coming in as this sum of Z's to form this series combination capital Z sub S. So now we can design or select those parameters in Z sub A and Z sub B, and it's easier actually to understand how adjusting parameters in Z sub A or Z sub B or in combination impacts the design. And what have we done? We've now turned this highly coupled analysis, if we think back where we started, if you now had to analyze this, you now have this 3-mesh or 3-node circuit to deal with. Now we've extracted from that or identified within that 2 series connected 2 ports, and it's pretty intuitive as to how to manipulate the parameters in each of those individual 2 ports in order to understand the analysis or to actually provide a way of designing some circuit that you might need to achieve a particular output current or a particular voltage gain, etc. And that's the whole point of this circuit analysis, is providing you with tools and skills and techniques and strategies to provide you insight into analyzing circuit behavior.